New Guinea, June 1943. A P-38 Lightning pilot screams into his radio, "I can't turn with them. The Zeros are inside my turn radius. I'm dead." His wingman watches helplessly as 3 Japanese Zeros close in. The P-38 is faster, climbs better, dives faster. But in a turning fight, a dogfight, the Zero wins every time. Lighter, more maneuverable, can turn inside any American fighter. This is the Pacific War's fundamental problem. American fighters are technologically superior, but tactically inferior in close combat. Pilots are told, don't dogfight Zeros, use speed, hit and run, boom and zoom. But combat doesn't always allow perfect tactics. Sometimes you get jumped, sometimes you're protecting bombers and can't run. Sometimes you have to turn and fight. And when P-38s turn and fight, they die. Until a mechanic named Charles Lindbergh, yes, that Charles Lindbergh, the famous aviator, arrives in the Pacific in 1944 as a civilian technical consultant. He's supposed to teach pilots fuel efficiency. Instead, he watches them fight, watches them die, and he notices something nobody else has noticed. The P-38 isn't turning as tight as it should. There's something wrong with the controls, something limiting the aircraft's maneuverability. Not a design flaw, not engine power, something mechanical, something simple. Lindbergh spends 3 days troubleshooting, testing, measuring. Then he finds it. A small wire in the control system, a safety mechanism installed during production, designed to prevent pilots from overstressing the airframe during high-speed maneuvers. The wire limits how far the control yoke can move, limits how sharp the aircraft can turn. It's a safety feature, perfectly reasonable for training aircraft or transport missions. But this is combat. Pilots need every degree of turning performance. The safety wire is killing them by preventing them from using the P-38's full capability. Lindbergh grabs wire cutters, walks to a P-38, cuts the wire, tells the pilot, "Try now." The pilot takes off, engages a Zero in mock combat, reports back, "It's a different airplane. I can turn inside him now." Not by much, but enough. Word spreads. Within 2 weeks, every P-38 in the Pacific has the wire cut. Within a month, Zero pilots are reporting American fighters that can suddenly turn with them. Within 3 months, the P-38's kill ratio jumps from 2:1 to 4:1, 1 wire, 1 pair of wire cutters, 1 mechanic's observation, and suddenly American fighters can fight Zeros in their own element. This is the story of how Charles Lindbergh's stupid little wire trick changed the Pacific Air War. How a safety feature designed to protect pilots was actually killing them, and how sometimes the difference between victory and defeat is noticing what everyone else overlooked. The P-38 Lightning was one of the most distinctive aircraft of World War II. Twin-engine, twin-boom design, central nacelle for the pilot. It looked like nothing else in the sky. Lockheed designed it in 1937 as a high-altitude interceptor. Fast, long-range, heavy armament, 4 50-caliber machine guns and 1 20mm cannon, all mounted in the nose. By 1942, P-38s were arriving in the Pacific Theater. American commanders were excited. Finally, a fighter that could match Japanese aircraft in range and speed. The Zero had dominated since Pearl Harbor. The P-38 was supposed to change that. It didn't, initially. The first P-38 units in the Pacific suffered heavy losses. Pilots reported, "The Zero can outturn us. We're faster, but in a dogfight, they win. Our tactics are boom and zoom, dive on them, shoot, climb away using superior speed. But if we get caught in a turning fight, we're dead." The kill ratio reflected this. Early 1943, P-38s were achieving maybe 2.1 kill ratios against Zeros. Acceptable, but not dominant. Pilots were frustrated. The P-38 was a beautiful aircraft, powerful. But it wasn't giving them the advantage they needed. The problem was well understood. The Zero was lighter. Japanese design philosophy sacrificed armor and self-sealing fuel tanks for maneuverability. Zeros were fragile but agile. P-38s were tough but less maneuverable. Physics, trade-offs, nothing to be done. Except everyone was wrong. Charles Lindbergh was 42 years old in 1944. He'd been famous since 1927 when he flew solo across the Atlantic. National hero, aviation celebrity. But by 1941 his reputation was complicated. He'd opposed American entry into World War II, given speeches critical of Roosevelt's foreign policy. Some accused him of Nazi sympathies. Unfair, but the damage was done. When Pearl Harbor happened, Lindbergh tried to rejoin the Army Air Corps. He'd been a reserve officer, but the Roosevelt administration blocked it. Political revenge. If Lindbergh wanted to contribute, it would be as a civilian. So Lindbergh became a technical consultant for United Aircraft Corporation. They built engines, including the ones powering P-38s. Lindbergh's job: travel to combat zones, teach pilots fuel management, help them get maximum range from their aircraft. He arrived in the Pacific in April 1944, visited units flying P-38s. His official job was fuel efficiency, but Lindbergh couldn't stop being a pilot. He flew combat missions, officially as an observer, unofficially as a fighter pilot. The military couldn't stop him. He was a civilian. If he wanted to fly combat, that was his problem. Lindbergh flew over 50 combat missions in the Pacific. He engaged Japanese fighters, shot down at least one Zero. Officially he was observing, so it wasn't credited. But he flew, he fought, and he observed, and he noticed something. The P-38s weren't turning as tight as they should. He'd flown P-38s stateside, tested them, knew their performance envelope. In combat, they weren't reaching that envelope. Something was limiting them. After a mission where he'd watched a P-38 pilot die in a turning fight with a Zero, Lindbergh started investigating. He talked to pilots. They all said the same thing. The control yoke feels stiff at high deflection angles. Can't get full throw. Can't pull into a maximum rate turn. Lindbergh checked the manuals. The P-38's design specifications said it should be able to turn tighter than pilots were achieving. So why wasn't it? He started examining aircraft on the ground, checking control linkages, looking for mechanical restrictions. Most mechanics assumed he was wasting time. The P-38 turned how it turned. That's just how it was. Then Lindbergh found it, a small wire cable in the elevator control system. It connected to a stop mechanism that limited how far the yoke could be pulled back. The wire was intentionally installed, part of the original design, not a defect, a feature. Lindbergh checked the technical documentation. The wire was a safety mechanism. It prevented pilots from pulling excessive G-forces during high-speed maneuvers. If you dove the P-38 at high speed and pulled back hard on the yoke, you could generate enough G-force to damage the airframe or cause structural failure. The wire prevented that by limiting elevator deflection. The logic made sense for training or transport operations. But in combat, pilots needed maximum maneuverability. The safety wire was preventing them from turning as tight as the airframe could actually handle. It was literally holding them back. Lindbergh did the math. With the wire in place, the P-38 could pull about 6 Gs maximum in a sustained turn. Without the wire, it could pull 7 to 8 Gs before structural limits kicked in. That extra G loading translated to a significantly tighter turn radius. Not huge. But in a dogfight, a few degrees of turn rate advantage could mean life or death. The Zero could pull about 7 Gs in a sustained turn. So with the wire in place, the P-38 was at a disadvantage. Without the wire, it matched or slightly exceeded the Zero's turn performance. Lindbergh approached a P-38 squadron commander, explained his theory. The commander was skeptical. If it was that simple, someone would have figured it out already. Lindbergh said, "Let me cut the wire. On one aircraft, we'll test it." The commander reluctantly agreed. They selected an aircraft. Lindbergh removed the access panel, located the safety wire, and cut it with wire cutters. Reinstalled the panel. The whole procedure took 20 minutes. A test pilot flew the modified aircraft, put it through aggressive maneuvers, came back excited. It's completely different. I can turn much tighter. The controls feel more responsive. I pulled harder than I've ever pulled before, and the airframe held fine. They measured the turn performance. With the wire cut, the P-38 achieved a turn radius about 15% tighter than stock configuration. 15% doesn't sound like much, but in a dogfight where aircraft are turning inside each other's radius, 15% is enormous. The squadron commander authorized cutting the wire on all aircraft in his unit. Within a week, his pilots were reporting dramatically improved performance in dogfights. One pilot shot down 2 Zeros in a single engagement using sustained turning combat, something previously considered suicidal for P-38 pilots. Word spread through informal channels. Other P-38 units heard about the modification. Pilots started cutting the wire themselves or having mechanics do it. By July 1944, most P-38s in the Pacific had the safety wire removed. The official reaction was complicated. Lockheed, the manufacturer, was initially horrified. You can't just cut safety systems. The wire was there to prevent structural failure. Removing it put pilots at risk. But combat data didn't lie. Structural failure rates didn't increase. In fact, combat losses decreased because P-38s could now fight Zeros more effectively. Pilots loved it. They wanted the wire gone. By August 1944, the Army Air Forces officially authorized the modification. Technical bulletins were issued. Remove safety wire from elevator control system on all P-38 aircraft operating in combat zones. The modification became standard. The impact on combat performance was measurable. Before the modification, P-38 units were averaging 2 to 2.5.1 kill ratios against Japanese fighters. After the modification, the ratio jumped to 4.5.1. The P-38 went from being adequate to being dominant. Pilots reported, "It's like flying a different aircraft. I can turn with Zeros now, not quite as tight, but close enough that my superior speed and firepower give me the advantage." Japanese pilots noticed too. Intelligence reports from captured Japanese aviators showed confusion. American fighters were suddenly more maneuverable. They didn't know why. Some speculated new aircraft models. Others thought improved pilot training. Nobody guessed it was a simple wire being cut. The modification had one consequence Lindbergh predicted: increased pilot fatigue. Pulling 7-8 Gs is physically exhausting. Pilots weren't used to it. Some blacked out in hard turns because they hadn't learned proper G-strain techniques. The solution was training. Pilots learned to tense muscles, use proper breathing and manage G-forces. Within weeks, most adapted. There were a few incidents of structural overstress. Pilots who pushed too hard in dives and pulled out too aggressively damaged airframes. But these were rare. Pilots learned the new limits quickly. The benefits vastly outweighed the risks. Lindbergh's contribution went beyond the wire. He also taught pilots advanced fuel management techniques. P-38s had 2 engines, which drank fuel. Lindbergh showed pilots how to lean the mixture, optimize cruise settings, and extend range by 30–40%. This allowed P-38s to escort bombers deeper into Japanese territory. But the wire cutting was his most immediate impact. One simple modification. No new technology, no redesign, just removing a safety feature that was inappropriate for combat conditions. Why hadn't anyone else figured it out? Several reasons. First, most pilots and mechanics assumed the aircraft's performance was what it was. They didn't question fundamental design. Decisions. Second, the safety wire wasn't obvious. It was buried in the control system, not immediately visible. Third, there was a general assumption that Lockheed engineers knew what they were doing. If they'd installed the wire, there must be a good reason. Lindbergh had the advantage of being both a pilot and an engineer. He understood aircraft systems deeply. He also had extensive experience with different aircraft types. He knew what performance to expect. When combat P-38s didn't meet those expectations, he investigated rather than accepting it. This pattern repeated throughout the war. Small modifications based on field observations often produced significant improvements. Another example, P-51 Mustangs originally had poor rearward visibility. Pilots requested bubble canopies. The modification improved situational awareness dramatically. Simple change, huge impact. The military's official recognition of Lindbergh's contribution was muted. He was still politically controversial. The Roosevelt administration didn't want to give him credit publicly, but among P-38 pilots he was a hero. They knew the wire modification saved lives. After the war, Lindbergh's wartime contributions were gradually acknowledged. He'd flown 50 combat missions as a civilian, shot down enemy aircraft, improved aircraft performance through engineering modifications, taught pilots techniques that extended range and improved survival. The P-38 went on to become one of the most successful American fighters in the Pacific. Top American aces flew P-38s. Major Richard Bong, America's highest-scoring ace with 40 kills, flew P-38s. Thomas McGuire, second highest with 38 kills, flew P-38s. Both benefited from the improved maneuverability the wire modification provided. The Zero, meanwhile, became increasingly obsolete as the war progressed. Its light construction, initially an advantage, became a liability. American fighters got better, pilots got smarter, tactics improved. By 1945, the Zero was outclassed. But in 1943, early 1944, the Zero was still formidable. The P-38 wire modification came at a crucial time. It gave American pilots a tool they desperately needed, the ability to turn with Japanese fighters without courting certain death. The technical details matter. The wire limited elevator deflection to about 25 degrees. Full deflection without the wire was about 30 degrees. 5 degrees doesn't sound like much, but elevator deflection translates directly to pitch rate and turn performance. That extra 5 degrees meant the aircraft could pitch up more aggressively, sustaining tighter turns. The structural safety margin was still present. The P-38's airframe could handle more stress than even the full elevator deflection would produce under most conditions. The wire had been installed with excessive caution, appropriate for civilian operations or training, but unnecessary in combat where pilots needed every bit of performance. Modern aircraft design learned from this. Safety systems are now designed with combat requirements in mind. Limiters exist, but they're set closer to true structural limits. The P-38 wire was set too conservatively, limiting combat effectiveness. Interestingly, some P-38s operating in Europe kept the wire. The combat environment was different. Luftwaffe fighters weren't as maneuverable as Zeros. European combat emphasized speed and altitude performance, where the P-38 already excelled. The wire removal was primarily a Pacific theater modification. This created documentation confusion after the war. Some P-38s had the wire, some didn't. Technical manuals were inconsistent. Restoration projects today sometimes debate, should the wire be present or not? The answer depends on which theater and time period you're representing. Lindbergh's role remained somewhat obscure for decades. He died in 1974. His Pacific wartime service was mentioned in obituaries but not emphasized. The political controversies of 1941 overshadowed his 1944 contributions. Only in the 1990s, 2000s did military historians fully document his Pacific service. Books were written, his combat missions were detailed. The wire modification was finally credited to him explicitly. Veterans confirmed it. P-38 pilots who'd flown in the Pacific remembered, Lindbergh came through, made a change, and suddenly we could turn with the bastards, changed everything. The lesson is applicable beyond World War II. Sometimes the solution to complex problems is simple. Sometimes expertise means questioning assumptions. Sometimes field observations trump engineering theory. Sometimes a wire cutter is more valuable than a slide rule. The P-38 Lightning was a good aircraft from the start. The wire modification made it a great aircraft. The difference between good and great was one mechanic noticing what everyone else overlooked. Zeros were still dangerous after the modification. They didn't suddenly become easy kills, but P-38 pilots went from defenseless in turning fights to competitive. That psychological shift mattered as much as the technical improvement. Pilots flew more aggressively, confident they could survive close combat. The kill ratio improvement from 2:1 to 4:1 reflects combined factors. Better maneuverability, better tactics, better pilot confidence, and improving overall American air superiority. The wire modification was one factor, but it was the factor pilots identified as transformative. One pilot wrote home in July 1944, "Something changed with our planes, can't say what for security, but we can fight now, really fight. Zeros are still tough, but we're tougher." That pilot survived the war. So did many others who might not have if the wire had stayed in place. Remember the opening, June 1943, a P-38 pilot screaming, "He can't turn with zeros." That was the problem Lindbergh solved. 1 year later, P-38 pilots were turning with zeros, matching them degree for degree, then using superior speed and firepower to finish fights. The solution, wire cutters and 20 minutes of work. The result, hundreds of lives saved, improved kill ratios, and American air superiority in the Pacific accelerated. Charles Lindbergh arrived in the Pacific to teach fuel efficiency. He ended up teaching American fighters how to win dogfights, not through new technology, not through better engines, through one simple observation. The aircraft can do more than it's being allowed to do. Cut the wire, let it fly. The P-38 Lightning with wire removed, suddenly capable of turning inside zeros, suddenly competitive in the one area Japanese fighters had dominated. One mechanic's stupid wire trick. Stupid because it seemed too simple. Stupid because nobody else had thought of it. Stupid because a famous aviator with wire cutters solved a problem that engineering teams had accepted as unsolvable. Except it wasn't stupid. It was brilliant. The simplest solutions often are. The P-38 went from good to legendary, not because of design changes or new engines, because someone noticed a wire that shouldn't be there and removed it. That's the story, that's the trick. One wire, one observation, one modification that changed the Pacific Air War. Simple, effective, overlooked by everyone until one man looked closer.